This project was completed by Brandon Harris, Michael Cantu, and Kelly Wachtel. The goal of our project was to familiarize ourselves with OpenAI Gym and some reinforcement learning algorithms that we learned throughout the quarter. To begin, we wrote the multi-arm bandit code, which was mainly learned in a machine learning course, and the Q-learning code to test out a simple OpenAI gym environment called Frozen Lake. The purpose of learning using both of these algorithms is to show the effectiveness of Q-learning's ability to use possible future moves to sway its actions one way or another via the Q-table. Multi-arm bandit does not use possible future state information to update its Q-table, and this is made evident by these lines of code that edit the Q-tables in multi-arm bandit and Q-learning respectively. As seen from the two graphs, Q-learning is much more deliberate when finding the highest reward, as it steadily increases as each iteration goes on. This is the cart pull example. The objective of cart pull is to get the pole to balance a pole on a cart. The pendulum starts upright, and the goal is to prevent it from falling over. A reward of +1 is provided for every time step that the pole remains upright. The episode ends when the pole is more than 15 degrees from vertical, or the cart moves more than 2.4 units from the center. This is the Acrobat example. The Acrobat system includes 2 joints and 2 links, where the joint between the 2 links is actuated. Initially, the links are hanging downwards, and the goal is to swing the end of the lower link up to a given height. For our cart pull, we start with selecting the environment, and here we have the C chosen as a good demonstrator of learning results as consistency. For our optimizer, we want to use Atom as the optimizer. For our while true loop, we loop until break condition is met. And then this loop represents an iteration through the game. And here we have our step function, which iterates the state, shows rewards, and tells us if the session has ended yet. Environment render here is the render function, shows us the game as the agent learns to play it. Here for our running reward, between iterations of the game, we update our cumulative reward, our policy, and our Q function. For the finished episode does all the heavy lifting in terms of updating the model. Here, if we have updated our model such that it exceeds our reward threshold, we have finished training. And I tracks loop iterations both for verbosity and a final check on total iterations. And here's our rewards for cart pull problem and our rewards for Acrobat problem. Thank you.